Okay, now we'll start today's lecture, which will be the integration of trigonometric functions. We will study here some standard forms for integration of in the trigonometric functions, which will be in this form: integration of sine power some number mx and multiplied by cosine power some number x. Okay, we will learn how to treat any integration in this form. Okay, now we have two cases or two types. First, if m or n is odd, whenever I find sine multiplied by cosine, each is to some power. Whenever I find one of them with an odd power, I just take one of these after the d. Okay, so if I have integration of cosine power 4x sine power 3x dx, I have seen that this is in this form: cosine power some number, sine power some number. One of them is odd. Whenever I find an odd power like this, what should I do? I just take one of them, I take it after the d. Okay, this is the easiest case. Whenever I find m or n odd, I just take one of them to be after the d. Okay, so how could I? Cosine power 4x sine squared x, and one of them it will be cosine x. Now what should I with minus? What should I do now? I just need to express all the integral in terms of the cosine x. Okay, I can call this y. How could I express sine squared in terms of cosine or not? 1 minus cosine squared. So this will be minus integration of cosine power 4x minus cosine power 6x d cosine x. If I call this y, the integral will be y power 4 minus y power 6 dy, which is a solvable integral. Okay, this happens for any integral which has some power of them odd, with these similar steps. Okay, the other case, which is a bit harder, which when I have m and n both are even. If I have m and n both are even, I must use reduction of order formulas, which are the formulas for double angle. Formulas for double angle. What are these? These are sine x multiplied by cosine x is half sine double angle, and cosine squared x is half 1 plus cosine double angle, and sine squared x is half 1 minus cosine double angle. Okay, and this applies for any angle. It just mustn't be x for any angles. For example, if I say sine 2x cosine 2x, it will be half sine double the angle, which will be 4x. Okay, if I have sine squared of 8x, what will be its reduction formula? Half 1 minus cosine double the angle, which will be 16x. Okay, why I'm calling it reduction of order? Because always in this side we have a second order or a second degree term. I have this a second degree, and sine and cosine I treat it as the same level of difficulty. So this is also a second degree term. They are converted to a first degree term, cosine power 1 or sine power 1. So I'm making some reduction of the difficulty. Okay? Now, if I have, how should I apply them? I apply them in this sequence. I just try first to find any of these that I can apply, then I apply one of these. Okay? Let's see some example. If I have, for example, an integration of sine squared x multiplied by cosine power 4x. We have here these two powers are even. Whenever I see sine multiplied by cosine, I just look for the odd. I look for the odd power. Why? Because the odd power is the easiest case. I just take one of them after the d. Okay. Now I don't find here any odd, so I have to make it by the reduction of formulas. How should I apply the reduction formulas? I just try to find first any of these. Sine x multiplied by cosine. So I express it like this: sine x multiplied by cosine x all squared multiplied by cosine squared x. Do you understand what I have done here?
Yes. Yeah.
Okay, I take the similar powers. This I take it cosine squared multiplied by sine squared, so that I can take these two to apply this formula. Okay, now this sine x multiplied by cosine x is half sine double the angle all squared, and this will be half 1 plus cosine double the angle, which will be cosine 2x. This will be 1 over 4, and half will be, I'll take it all out the integral. What will be here? Sine squared 2x multiplied by 1 plus cosine 2x. Okay, now I have two integrals. This is 1 over 8 integration of sine squared 2x plus the integral of sine squared 2x multiplied by cosine 2x. This one, sine squared, I have learned before how to treat sine squared, or I can look at it by this new lesson, which is sine squared multiplied by cosine power 0, which is all even. So I have to apply the reduction formulas. I have to apply reduction formulas here. This will be 1 over 8 integration of half cosine 1 plus cosine 1 minus cosine double the angle, which would be 4x. Okay, plus sine multiplied by cosine. I just look for any odd power. Can I find here any odd power?
Yeah.
Where is the odd power? Yes, I have this an odd power. Whenever I find an odd power, what should I do? I take it after the d. So now this is sine squared 2x d sine 2x divided by 2 for making the integral. Okay, now this all of these integrals are manageable.
Yeah.
Integration of 1 is x. Integration of cosine x is sine 4x but divided by 4. Okay, what about this integral? Sine squared 2x d sine 2x. We have learned whenever I change what after d, I can call it y. This is y. So this integral is just integration of y squared dy, which is y power 3 over 3, which is sine 2x or power 3 by 3. Okay, so we have managed to solve this integral. Any integral with all even powers, we learned how to make it. Okay, now let's see some examples on applying these formulas. If I take integral of root sine x cosine power 5x dx.
One is odd.
I just,
One is
yes,
odd.
one is odd. Whenever I find an integral with sine and cosine, I just look for the odd power. Whenever I find an odd power, I just take one of them after the d. So now this will be sine x cosine power 4x d sine x. I just need to express cosine power 4 in terms of
Sine.
the sine x. How should I express cosine power 4 in terms of sine? So what is cosine power 4x? Is it 1 minus sine power 4x? No.
This is
I just has to say to express it as cosine squared all squared. Yes. So this will be integration of root sine x 1 or half 1 minus no. I'm not using the reduction formulas here. 1 minus sine squared x all squared d sine x.
Yes.
If I say this, I take this as a substitution by y, it will be root y 1 minus y squared all squared dy. So this is the new integral. This is manageable. How? Root y 1 minus, I just expand this.
Yeah.
2y squared plus y power 4 dy. Then I multiply these, then I make the power rule. Okay?
Yeah.
So what about this integration of sine power 4x dx? Can I find in any odd power? No. So I have to use the reduction formulas. The reduction formulas here, which is sine. Yeah, I just try first to find sine x multiplied by cosine x. I can't find here this. So I only find here sine squared, which is, so now this is half 1 minus cosine double the angle 2x all squared. This will be 1 over 4 1 minus cosine 2x all squared dx. I expand this bracket. 1 minus 2 cosine 2x plus cosine squared 2x. It will be x minus integration of cosine to x, which is sine 2x over 2. I have here 2, so this will be eliminated by this. Now plus this integration of cosine squared. Cosine squared, I have to make a reduction, which is half 1 plus cosine, double the angle, which will be 4x. So this integral will be half x plus sine 4x over 4 like this, and it will be plus c. Okay, we have learned how to treat any case of these. If I had integration of 1 over sec squared x cosec squared x.
Convert them into
1 over sec squared or 1 over cosec squared, this is just
Sine.
cosine squared x multiplied by sine squared x. I look for the odd power. There is any odd power? No. So I need to apply the reduction formulas. I apply the reduction formulas by finding first any sine multiplied by cosine. Could I find here any cosine multiplied by sine?
Yeah.
Yes, it is here. I can express this as cosine x sine x all squared. And I apply the reduction formula for this one. This will be half sine double the angle all squared dx, which will be 1 over 4 integration of sine squared 2x dx. This is the new integral, and it is sine squared. How?
في reduction here.
Make the reduction formula again, which would be 1 over 2 integration of 1 minus cosine double the angle, which would be like this. This will be x, and this will be sine 4x over 4.
Plus it.
Okay?
Yeah.
So we have studied now the two cases for finding any odd, for finding odd power or an even power. Okay? The first type of trigonometric integrations, which is the integration of sine power nx cosine power mx. The other type is integration of sec power nx multiplied by tan power mx dx. And another similar one, which will be treated the same way, cosec power nx multiplied by cotan power mx dx. Okay, we'll learn how to deal with these two types. And the treatment of this integral is similar to this one. Okay? We now have three cases. In this one we had only two cases. If one of them is odd, I take one of the odd after the d, and the other I use the reduction formulas. Now I have three cases. If I have here the power of tan positive integer, power of tan positive integer. The other case is power of sec positive power of tan is odd positive integer, power of sec is even positive integer, and the other case is otherwise. If I have the power of tan odd positive integer, I take sec tan after the d. Whenever I find the power of tan is odd, power of tan positive odd, okay, I take sec multiplied by tan, I take it after the d. When the power of sec is even, I just take sec squared after the d. This I will treat this case in afterwards, after studying these two. Okay, let's see examples in these two. For example, if I had this integration of tan power 3x sec power x dx, sec x dx. Now I have the power of tan is odd. Okay, now whenever I have tan x multiplied by sec, tan power some number, sec power some number, I look for an odd power for the tan or an even power for the sec. Okay, I look for an odd power for the tan or an even power for the sec. Whenever I find any of these two, I just treat it by this way. For the odd power of the tan, I take sec tan. If I have an even power for the sec, I take sec squared. Okay, now for this case, this I take sec tan after the t, because I have here an odd power for the tan. So this will be tan squared x sec tan. I take it after the d, which will be d sec. What should I do now? I have to express what is remaining in terms of what is after the d. Okay, so this is sec squared x minus 1 d sec x. If I call this y,
It's y.
so this integral will be y squared minus 1 dy, which is solved. Just saying that y is sec x. Okay? Now, if I have this integration of tan power 4x sec squared x, I look for an odd power for the tan or an even power for the sec. Which case is this?
Even power for sec.
Even power for the sec. So how should I deal it? I just take sec squared after the d. Now this is tan power 4x d tan x. This is already solved, which is tan power 5 over 5 plus c, because this is integration of y power 4 dy.
Yeah.
If I had this integration of sec power 4x over tan squared x dx, I have here an even power for the sec. When I have an even power for the sec, I just take sec squared after the d. So now I have sec squared x, and sec squared here is taken after the d. It will be d tan over tan squared x. I just need to express the sec squared in terms of tan x, which will be 1 plus tan squared x. So now this integral will be, if I take this, I call it y 1 plus y squared over y squared dy. Can I solve this integral?
Yeah.
Yes, and this can be distributed as 1 over y squared plus 1, which will be minus 1 over y plus y. And the y is tan x. If I have this integral of tan cubed x sec cubed x,
Sec tan e.
I am looking for an odd power of the tan or
Even.
an even power of the sec. Which case is this? An odd power for the tan. So I just take sec tan, I take it after the d. So I have here tan squared x sec squared x. I have taken a tan from here and a sec from here.
Sec d.
D sec x. I just need to express the remaining
And sec.
integrand by in terms of sec. I just express tan squared in terms of sec, which will be sec squared minus 1. So the integral will be sec power 4x minus sec squared x d sec x, which is integral of y power 4 minus y squared dy, and y is sec x. If I have an integral of tan power 7x multiplied by sec power 4x, I'm looking for an even power of sec or an odd power of tan. Now, which case is this?
Both.
Both. Yes, so I can use any of the two methods. Okay, but which one is easier? Which has the less power?
Sec.
Which is sec. So this is the less power here. I would take sec squared from this. Tan power 7x sec squared x d tan x, and just I express this in terms of 1 plus tan squared. I can also solve it by taking sec tan after the d. but it will just need some expansions or more work than this one. Okay. If I have integration of tan x root sec x, we have here an odd power of the tan. We have here an odd power of the tan. So I take sec tan after the d, but there is no sec here. No problem. I just multiply by sec x and divide by sec x.
Okay.
Now I can take sec x tan x after the d, which is d sec x root sec x divided by sec x, which is integration of dy root y over y, which is solvable also. 1 over root y dy. After simplification it will be 2 double the root. Okay. What about this case? The remaining case, which is tan x multiplied by tan squared x multiplied by sec x. Now we have an even power for the tan and an odd power for the sec. How would I deal with this problem? In this problem, this is solved by parts. It is solved by parts, and it is, whenever I find this case, we will have the case of finding an integral returning to its original in the by parts, which is one like the exam, which was sec power 3x dx. This was solved by parts and it returns to its original. How? I just look at this tan squared sec x. I take here what is available, if sec squared or tan multiplied by sec.
Sec by tan.
I take sec by tan after the d, so it remains tan x d sec x. I apply by parts, which is u dv tan x sec x minus integration of v, which is sec x, du derivative of tan, which is sec squared. Okay. Now I just need, whenever I have this, I just need to sec tan d sec yes, in this integral I just need to express it in terms of the original integral. What is sec squared? Can I express sec squared in terms of this integral? Yes, this is tan 1 plus tan squared. Okay, so this integral will be tan x sec x minus integral of sec x multiplied by 1 plus tan squared x. Okay, now these steps, you should be trained on these steps. Okay, this formula is just standard. So I just make by parts the resulting integral. I express it in terms of the original integral by the trigonometric formulas that I know. Okay, now this sec multiplied by 1 plus tan squared, which will be tan x sec x minus integration of sec x dx minus integration of sec x tan squared x. What is sec x tan squared x?
Original.
It is the original integral, which is I.
I.
So I is equal to tan x tan x minus integration of sec. So now I have 2I is equal to tan x sec x minus integration of sec x, which is ln sec x plus tan x, like this. I will be half of these plus c. Okay? Similar to this one, which is the integral which we have studied before in, or the one which came in the exam, which is cosec power 3x dx. This integral has an odd power for the cosec and an even power for the tan. What is the even power of the tan? It has here of the cotan. It is power 0. I just treat it as if there is here a cotan, but it's raised to power 0. Okay? Now this cosec power 3x. So this is the case which is solved by parts and it returns to its origin. So I have in my mind that I have to, whenever I apply it by parts, I just have to express it in terms of the original integral. Okay? Now, how should I make it? I take cosec squared, I take it after the d, which will be cosec x d cotan x in negative. I apply by parts, u dv will be minus cosec x cotan x minus integration of v, which is cotan, du, the derivative of cosec, which is cosec cotan, cosec cotan, and in negative. So it will be like this. Now I have applied by parts. I just need to express this in terms of the original integral. So what will be? I take the cotan squared, I express it in terms of the cosec, which will be cosec cubed x squared x minus 1 multiplied by this. Now minus cosec x cotan x plus cotan. Now this is cosec integration of cosec cubed x dx minus integration of cosec x dx. But remember here this minus is distributed on this and on this one, which will be minus here and plus here. I'm expecting that after making, I'm expecting to express it in terms of the original integral. Here is the original integral. I, which is I. Now I have I is equal to, now I have 2I is equal to minus cosec x cotan x plus integration of cosec x, which is ln cosec x minus cotan x, like this, all plus c after dividing by 2. Okay? Now we have learned how to treat any of the trigonometric forms. Okay? Now we take a break of 10 minutes.